Let's move now to another topic that is AI on the edge in the fleet management. In this session, we will focus on one of the most challenging aspects in the modern embedded system, that is artificial intelligence running on the edge. In this year, AI is moving rapidly out of the cloud and into the edge device themselves. This shift opens incredible possibilities for the companies, for the manufacturing, for the industrial automation, and for the connected products, but it also introduces a new set of non-trivial challenges. Most embedded devices were not designed with AI in mind. The devices that are on the field, unlikely servers or GPU in the cloud, have not the CPU and the memory power of the server. So CPU and memory and RAM is limited. There are strict power requirement. There are also thermal limits and intermittent connectivity. And in the edge device, there are many times also real-time constraints. And this means that the deploying a neural network, an AI algorithm, is not a simple copy the model in the device and run the inference in the device, but the manufacturer must ensure, for example, deterministic latency and execution, and the no interference with the critical tasks that are performed in the device. So the AI must run in a reliable way on the device that were never intended to run the device, or the AI must run in a reliable way on the device that have a strict requirement for hardware acceleration, for example. A model trained on the cloud or on a workstation cannot be deployed directly on a microcontroller or an embedded Linux board, as we said, for the requirement limitation that we have. So every AI model needs quantization, pruning, compression, and adaptation to the hardware acceleration that is available on the device. And we also need to guarantee the compatibility with an heterogeneous set of chipsets that are available in the market. This creates a fragmented and complex toolchain landscape with different devices in the fleet that may use different CPU and even different accelerator like neural processing unit, NPU. This is a big challenge in the deploying one model across many devices because the devices are all different. Deploying a model once is an easy part, but we also the real challenge is to keep the model valid and updated for years across thousands of these devices with new hardware. The environment, the operational environment is evolving. We receive new data, so the model can drift. And maybe there are new algorithms or improvement. So the model lifecycle has to manage all these requirements. We need versioning of the model. We need to coordinate the model with the over-the-air update and rollback. Maybe we need the A/B testing too. And we need to test and to check the compatibility and dependencies across the whole system to synchronize the firmware, the operating system, and also the model that are deployed on the device. And this becomes also more complex if the update must be differential and to save bandwidth in embedded device with low bandwidth available. So once deployed, an AI must be continuously validated and monitored to uh, monitor all the drift of the model, confidence score, for example, and have insight on how the AI model is performing on the field. Otherwise, the AI becomes a black box, and disconnected device may operate for years without knowing what is happening. So there is a growing need of model integrity, data authentication, and traceability of this model to solve all this problem. One of the most important challenges in the edge AI is data privacy. In a field like industrial, medical, or consumer device, often there are personal data or operational data protected by NDAs or safety critical information or commercial sensitive metrics that are recorded by the device. And these data cannot always be sent to the cloud to be used for training or for analysis. Also, the regulation like GDPR and NISA or the medical standards make the centralized learning difficult. So there are two emerging technologies that helps to address this problem. One is called federated learning, where the models are trained locally on the device and only the gradient, the trained models are sent to the central server that merge all the trained model together. So the raw data never leaves the device. The other approach is the split learning. In this approach, the model is split in two parts. The front portion run on device and the back portion runs on the cloud or in a powerful edge server. So only the result after the front partition is sent to the cloud. And so the raw data stay on the device and only an intermediate representation is transferred. Both these methods are powerful, but require a lot of orchestration, secure communication, privacy mechanism, and reliable update to work. All of these features are included in the ToloMEO AI modules that address all these challenges in a structured approach. The modules provide the capabilities that we need to build, deploy, and operate an AI model in embedded fleet. Some core features of the ToloMEO AI modules are the model lifecycle management from the creation, optimization, deployment, and monitoring of the model with the versioning and rollback, and also the monitoring of the performance. In ToloMEO platform, we have a pre-built and ready-to-use edge device model to accelerate the development of your application. For example, we have object detection, people counting, occupancy detection, event classification, and some simple anomaly detection pipeline that are ready to use for your application. We also have a stage for model optimization for the edge device. So you can upload your model trained on the cloud, and the ToloMEO platform can can do the quantization and the optimization of the model to run in a properly and efficient way on the target device. ToloMEO also manage the fine tuning of the model, so you can upload new data on your model, and the ToloMEO take care of the final training of the model to be more accurate for your task. We can also do the full model retraining in ToloMEO. You need more data, but ToloMEO can train from scratch a model that can run on your edge device. Last part of the ToloMEO AI module is the monitoring section that can track the usage of the model, the inference performed by the model, and all the metrics related with the AI in the field. In conclusion, Edge AI is powerful, but has a lot of constraints. Model must be optimized, portable, and also energy efficient. Deployment is only the beginning, but you have to take care of the whole life cycle management of your model, and you need monitoring of the performance. ToloMEO O.S is bringing all these pieces together and can help you to develop products with AI enabled on the edge.